Okay, welcome student. Now we'll be discussing on the part 4 from the chapter 13, which is on surface area and volume. Okay, now coming to this exercise 13b with the first problem from here. The dimension of metallic cuboid are 100 cm multiply 80 cm multiply 64 cm and is melted and recast into a cube. Find the surface area of a cube. Okay, now the dimension, what is the dimension? Dimension is the length, breadth and width of a cuboid. Length is 100 cm, breadth is 80 cm and width is 64 cm. Okay, now out of this metallic cuboid, this has been recast into a cube. What is a cube? Cube is a cuboid in which all the length of its side are equal. This means the length, breadth and height, they are of the same length. Okay, now what will be the surface area of cube? How many faces does a cube have? A cube have 6 faces, isn't it? Surface area will be 6 multiply a. 6a. If a be the length of the side, then the surface area will be 6a. Okay, now to get the value of a, the value of a side of a cube, we have to find out first with the volume of a cuboid, which should be equal to the volume of a cube. Why? Because it has been melted and recast into a cube. That means the volume of a cuboid should be equal to the volume of a cube. Okay, let us start with the solution on this. We know that the volume of a cuboid is length, breadth multiply height. That is with the given dimension 100 multiply 80 multiply 64, which give us how much? 512,000 centimeter cube. You just multiply this, you will get 5,12,000 centimeter cube. Now since the cuboid is recasted into cube, volume of cube should be equal to the cuboid. That means volume of cube is a cube, isn't it? Volume of cube is a cube. If length is a, then volume will be a cube. A cube is called this much. Then if you find a factor of 512,000, you'll find that it is a cube of 80 centimeter. Okay, it's a cube of 80 centimeter. A cube is called 80 centimeter cube. Cancelling this cube from here, you will get a equal 80 centimeter, not cm cube, is 80 centimeter. Okay, I said that you just cancel. Actually it is a cube. If you take to the right side, it will be a cubic root of 80 centimeter cube. Cubic with a cube will get cancelled. You'll get only a is called 80 centimeter. Okay, now if a is 80 centimeter, surface area of a cube, it has 6 faces. That means 6a square. 6 multiply 80 centimeter square of that. 80 square will be 64. 8 square is 64. That means 80 square will be 6400. Multiply with 6, you will get 38400 centimeter square. Area is in square unit. Okay, now this will be the surface area of a cube. Next, with the problem number 2, a cone of height 20 centimeter and the radius of base 5 centimeter is made up of modeling clay. Okay, a cone of the given height and of the given radius is made up, and a child taking that cone, he is making it in the form of a sphere. He take that clay, reshape it, and make a sphere out of this cone. We have to find out the diameter of the sphere. The same thing here also. We have to find out the volume of the cone, and after getting the volume of the cone, this volume of the cone should be equal to the volume of the sphere, isn't it? Now from there we can find out the radius of the sphere, and finally diameter of the sphere by from where? How? Because diameter is radius plus radius, isn't it? Now solution for this, let is given that the height of a cone h is 20 cm and radius r is 5 cm, and let r be the radius of the sphere. Okay, r be the radius of the sphere, and we know that the volume of the cone is 1 by 3 pi r square h. This is the volume of the cone. This is the formula. Right in the part 1 I've told you to remember the formula that we have for all the different type of figure we have I've described there in part 1. The volume of cone is this much, and volume of sphere is 4 by 3 pi r cubed. Okay, now since the volume of since it's been reshaped into in the form of a sphere, the volume of cone and the volume of sphere should be equal. That means 4 by 3 pi r cubed should be equal to 1 by 3 pi r square h. Cancelling pi from left and right, 3 which is in denominator, here also 3 is in denominator, you can cancel 3 also, and you will be remaining with 4 r cubed on the left, and the right side r square h. Okay, that means r cubed will be r square h divided by 4. Now substitute the value of r and h. R is 5 cm, h is 20 cm, isn't it? See here on the figure also, height is 5 and radius of a cone is 20 cm. Substitute the value of r and h divided by 4. 4 with 20 you will go how much? 4 with 5 is 20. Now here 5 square mean 5 multiply 5. With this 5 from here you will get 5 cubed. Okay, r cubed will be 5 cm cubed. Again taking this cube from here to right side will be a cubic root of 5 cm cubed, cancelling the root and the root sign and the this power of this 5 cm, cancelling, you will get r to be 5 cm. Hence the diameter of the sphere will be twice of radius, twice of r, twice of 5 cm will be 10 cm. Clear? Next we move with the problem number 3. A metallic spheres of radii 6 cm, 8 cm, 10 cm respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Same thing, melted, recasted, then reshape. All these things means we have to make sure we have in all this problem from here, one figure is being recasted or melted, mean the volume of each of this figure should be equal. Okay, here I've shown you here in a figure also. This sphere, the first sphere will take as radius r1, the second sphere of r2, and the third sphere of r3. All these 3 spheres have been melted and form a single solid sphere, and will take the radius of this resulting sphere as R4, R1, R2, R3 melted to form a big sphere of radius R4. Okay, here let R1, R2 and R3 be the radii of the three spheres, okay, and R4 be the radius of the solid sphere. As the three spheres are melted and form a solid sphere, therefore the volume of the solid sphere should be equal to volume of the three spheres. Okay, now what is the volume? Volume is 4 by 3 pi r cubed. Solid sphere is having radius R4. Then the same formula for all these three also, 4 by 3 pi r cubed. Just substitute the R1 for smaller circle, R2, then R3. Now on the left side is the same. On the right side, if you look on the right side, 4 by 3 pi, here also 4 by 3 pi, here also 4 by 3 pi. That means 4 by 3 pi is common. You take 4 by 3 pi common. Inside bracket you have R1 cubed, R2 cubed plus R3 cubed. Now from the left and right side, 4 by 3 pi, 4 by 3 pi, you can cancel. Remaining only R4 cubed is equal to R1 cubed plus R2 cubed plus R3 cubed. Now time for substituting the value of R1, R2 and R3. R1 is 6 centimeter, R2 is 8 and R3 is 10. 6 cubed means 6 multiply 6 multiply 6 would give us 216. 8 multiply 8 multiply 8 also 512, and 10 multiply 10 multiply 10 is 1000. Okay, adding these three you'll get 1728. R4 cubed is equal 1728 centimeter cubed. Then R4 will be a cube root of 1728. Okay, it should be like this. Okay, it should be cube root of 1728. Now since cubed here centimeter is in cubic unit and cube root, therefore centimeter will be taken outside. Okay, only centimeter. And 1728 also, if you find the factor of 1728, you will find that 1728 is a factor of 12 multiply 12 multiply 12, 12 cubed. Therefore R4 or radius of the big sphere will be 12 centimeter. Hence the radius of resulting sphere is 12 centimeter. Okay, now next with the problem 4. A solid metal cone with radius of base 12 centimeter and height 24 centimeter is melted to form a solid spherical ball of 6 centimeter each. Find the number of ball formed. Okay, here I've shown you in a figure. This is the cone, metal cone, base radius 12 centimeter, height is 24 centimeter, and this is melted to form a small spherical ball of diameter 6 centimeter. Find the number of ball. If a big cone, if you melt it and make small ball, that means you will get many balls, isn't it? But how many ball you will be getting, that we have to find out. How many ball we are getting, that means you have to find out the volume of a cone, how much it is, and that volume of cone divided by the volume of this spherical ball will give you the number of ball formed. Okay, now going to the solution of this. A cone is given radius to be 12 centimeter, height is 24 centimeter, and in a sphere the radius, let us take with capital R. Radius is how much is not given, is given the diameter. That means diameter, radius will be diameter divided by 2, which is 6 centimeter by 2, which will give us 3 centimeter. Now the number of ball formed will be the volume of the cone divided by volume of a sphere. Now what is volume of cone? Is 1 by 3 pi r square h. Volume of sphere is 4 by 3 pi r cubed. For the cube, you have taken capital R to be the radius. Okay. Now, substituting the value of R and R, H and R for the sphere, R radius for a cone is 12 centimeter, height of cone is 24, and R, capital R, is the radius of the sphere, which is 3 centimeter. Now substituting the value of this, you will get how much? Okay, before that, here 1 by 3, 4 by 1 by 3 divided by 4 by 3 can be written as 1 by 3. You change this division sign to multiplication sign. 4 by 3 will be 3 by 4. Cancelling 3 3, you will get only 1 by 4. That means from here you will get only 1 by 4. Now 12 square is 144. Okay, and 3 cubed is 333. 3 multiply 3 9, 9 multiply 3 is 27. Now from here is centimeter, from here centimeter, from here centimeter square, from here centimeter, means centimeter cubed. Numerator, denominator also centimeter cubed. Cancelling this centimeter cubed, I mean there is no more unit. And here if you cancel all this term, what will be remaining? You'll get only after cancellation, after simplifying this, 144 divided by 4 will be how much? 4 3 is 12, then 24 4 6 isn't it? Mean 36. You do the calculation here, you do the cancellation here, and at last you will get to be 32. Okay, you will get the number of ball will be 32 from here. Okay, these are the small thing that you can do it by yourself also, cancelling this. Okay, now coming to the next on the problem number 5, the radii of internal and external surfaces of a hollow spherical shell are 3 centimeter and 5 centimeter. The internal, the radius here is radius of the internal spherical shell is 3 centimeter. External hollow spherical shell is 5 centimeter centimeter, and this shell is being recast, is melted and recast into a solid cylinder of diameter 14 centimeter. We have to find out the height of the cylinder. Okay, here I've shown you in the figure that this is a shell of internal radius 3 centimeter, external is 5 centimeter. Diameter of a cone, or not a cone, diameter of a cylinder is 14. This means radius should be half of that, it is 7, isn't it? We have to find out the height of a cylinder. Okay, let R1 and R2 be the radii of internal and external hollow spherical shell of 3 centimeter and 5 centimeter. Okay, and radius of cylinder denoted by R, capital R, diameter by 2 is given in cylinder is given by the diameter, that is mean 14 by 2, which is 7 centimeter. Since the spherical shell is recast into cylinder, therefore the volume of cylinder should be equal to the volume of the spherical shell. That means volume cylinder is how much? Pi r square h should be equal to volume of sphere is 4 by 3 pi r2 cubed minus r1 cubed. External radius minus internal radius. Okay, now from here you can cancel pi on the left, pi on the right. Okay, pi on the left and pi on the right. Then you take only h on the left side, r you cross multiply to the right side, r square you cross multiply to the right side. That means you will have 4 by 3 multiply with r2 cubed minus r1 cubed divided by r square. Okay, now time for substituting the value of r1, r2 and capital R. R1 is how much? R2 is 5, therefore 5 cubed minus 3 centimeter cubed by r square 7 centimeter square. Now 5 cubed is how much? 125. 3 cubed is how much? 27. 7 square is how much? 49. That means h will be 4 by 3, 125 minus 27 by 49. 125 minus 122 minus 27, you will get 98. Denominator you have 49. Here is centimeter cubed by centimeter square. Cancelling centimeter cube, centimeter square, you will get centimeter remaining. Now 49 multiply 2 is 48, 2 multiply 4 is 8 by 3. Now if you divide 8 by 3, you will get 2 by 3 centimeter. 3 2 is 8, remaining 2, isn't it? This means if you put it in improper fraction, your height will be 2 by 3 centimeter. Okay, now is the end of this part 4. We try to listen again carefully with this video until you are clear with this, and on the next class we shall discuss on the next part, which is the part 5 of this chapter 13. Okay, for the time being we'll stop here. I will continue it again on our next class. Okay, bye to all of you.